Now let's see how we can use the chain SOP to copy the geometry onto the curves. So the chain SOP is much more robust way of copying the geometry onto the curves. So let's see how we can set it up. So let's create a geometry node and dive inside. Let's create a line. And let's increase the line length to 5. And let's create a box. So here we have a box. And let's add a chain SOP. So the chain SOP has two inputs, geometry to repeat and the required curves. So let's connect the line to the curves, set the display flag to the chain. So here, as you can see, we are copying the box onto the line, and here as you can see, if I set the display flag onto the line and enable the point display, here as you can see we only have 2 points. So unlike the copy to points or curve SOP, it's not using the points to copy the geometry onto the curves. Instead, it's using the curve length as well as the size of the geometry to calculate the number of pieces to fit onto the curve evenly. So if I go into the chain SOP, so here as you can see the number of pieces is set to the fit pieces along curve, so which means it's using the curve length and the size of the geometry to fit as many pieces as it need to fit the curve. We can change this to explicit number. So let's say if I want to copy 6 pieces, I can set it here. So now here as you can see we have 6 boxes, and we can adjust the spacing of these boxes by going to the alignment. So here we have the piece spacing, so let's increase that. So here as you can see we have the spacing, and the chain SOP also recognizes multiple geometries input as well. So let's say if I connect a sphere, and let's merge these two objects. So here as you can see the sphere has been included automatically, so I can keep adding more geometries. Let's add a platonic. Let's merge it into the stream. So here as you can see the platonic has also been added. Okay, so let's go into the chain SOP and let's decrease its spacing and go into the chain pattern, and let's change the number of pieces to fit pieces along curve, and let's add a transform node to scale our geometry down. So here as you can see, as I'm scaling my geometry down, so more of the pieces are required to fit onto the line. Okay, so let's add a truss geometry rubber toy into our geometry library. So now here as you can see, because our rubber toy has multiple connected geometries and it is using the connectivity SOP to determine how many geometry pieces has been connected in its input stream. Okay, so we can use the pack node to pack our rubber toy onto single point. So now here as you can see we have one packed geometry. So if I set the display flag onto the chain SOP, now the chain SOP is working correctly, and here onto the pattern we can cycle between our geometries. So now we are cycling by 3, which means now that the last piece has become the first piece. We can also change this to random, and we can change the random seed to randomly copy the geometry onto the curve. Let's change it back to cycle, and here we have the start and the end pieces. So which means we can define at the start of the curve which geometry we want at the start and which geometry we want at the end. So we can select that. So right here, as you can see, it's showing me the numbers. So we can change this to name by creating a name attribute. So let's go back into the merge, and here let's set up our name attribute. So let's create an attribute create node, and let's connect that, and let's set the name to name, and it should be a primitive, and the type set to string. Let's name our box to box. Let's duplicate this node, connect it to the sphere, and let's change this to sphere. Duplicate again, and here let's name this to platonic, and here let's set this rubber toy, and here onto the chain SOP. So where it says find pieces by connectivity, let's change this to by piece attribute, and it is looking for a class attribute, but we have set it an attribute name. So let's change this to name. So now it is recognizing our name attribute, and now here onto the start cap piece we have all our names. So at the start I want it to be box, and at the end I can use the platonic. So now here, as you can see, at the start I have box, and at the end we have the platonic. And here we have the checkbox to exclude end pieces from pattern, so which means that the pieces that we have defined in these slots will not be included in the geometry repetition. So we can uncheck that if we do want these pieces, and let's increase the line length. So here, as you can see, now we do have those pieces, but at the start we will have box, and at the end we will have platonic. So now let's create a chain using the chain SOP. So first let's create a chain link. So let's create a grid, set the display flag to the grid, and let's set the rows and columns to 2 by 2. Let's change the size X to 1.4, 2.9, and let's add a poly bevel, and I want to bevel my points, so let's change this to points, and let's increase its distance and add some division for more smoother corners. And now let's add a polybar. Let's add some division for more smoother look, and let's uncheck our UV visualization. And let's increase the wire radius, and let's add a helix to create our curve. So let's set the display flag to the helix. Let me increase its height and decrease the turn. And let's add a height ramp. Okay. Let's add a chain SOP. So these are our geometry, these are our curves. Set the display flag to the chain SOP. So here, as you can see, the chain SOP is not working correctly. So let's change some settings. So to avoid the pieces deformation, let's go into the rigidity and let's enable the rigidity. So now here, as you can see, we are not deforming our geometry. so the geometry size is big. Let's add a transform node. Let's scale it down by changing the uniform scale to a lower value, something like that. And let's go into the chain SOP and onto the alignment. Let's add a piece rotation. Let's add a rotation of 90 degree, and let's adjust our piece spacing in the negative direction. Okay, so here we have the very basic chain. Okay, and we can also use the chain SOP to animate our geometry onto the curve. So if I go back onto the chain SOP, so here where it says number of pieces, let's change this to explicit number, and let's add only one geometry onto our curve. And here onto the offset position, let's increase that. So here, as you can see, by adding the offset position, so let me template my helix. So if I enable, now if I add offset, here as you can see, we are animating our geometry along a curve. Okay, so let's create another example. So let's create a box, set the display flag to the box, and let me decrease its X size, and let's add a poly bevel. And let's add some divisions for more smoother bevel. And now let's add some holes into our geometry. So let's create a grid. So here we have the grid. Let's change the orientation to YZ plane, and let's add a match size node. So this is the geometry, and let's use this box as a reference geometry, and let's enable scale to fit. So now our grid has exactly the same size as our box. Okay, now let's create a tube. Let's change its orientation to X, and let's decrease our radius down, and also add the end caps. Also increase the columns for more smoother, slender. And let's copy our tube onto the grid. So let's add a copy to points SOP. So this is my geometry, and I want to use my grid points. So here we are creating lots of copies we don't need. So let's go into the grid. Let's change the rows and column to 2 by 2. So let's go back onto the tube, and let's change the orientation to Z-axis. So now they are oriented in the correct direction. So if I template my box, here as you can see, we have these cylinder in the correct orientation. Let's also decrease the radius even more. Let's add a transform node after the match size. So we are basically, let me untemplate my box. So here we have the grid. So let's decrease the grid size a little, And if I template my box again, so let's decrease the scale even more, something like that. And now let's use these cylinder to boolean out from our box to create holes. So let's add a boolean node. So this is the geometry A and this is the geometry B, and here we have these holes. Let's duplicate our setup. So these are our tube and this is the copy to point sub. So let's duplicate it here and let's merge it. So here onto this tube, let's decrease its height and let's also decrease the radius just a tiny bit so that we can see a little bit of hole. And let's go back onto the tube. Let's replace it onto the Z direction, something like that. So this is my piece that I want to repeat. So let's copy this setup. So where we have created the helix and the chain saw. So let's duplicate this whole setup and let's use this as our geometry. And let's set the display flag onto the chain saw. So onto the chain saw, we have set the number of pieces to 1. Let's change this to fit pieces along curve. So the scale is not correct. So let's add a transform node to scale our whole geometry down by changing the uniform scale. And because our model is made out of different connected pieces, so that is why the chain saw is copying each pieces individually. So let's go back onto the chain saw, and where it says find pieces by connectivity, let's change this to by piece attribute, and let's go into the alignment and let's zero out our piece rotation. We don't need that. And let's change our forward direction from Z to X. So now it is using the correct direction to copy our geometry onto the curve. Okay. So let's go back onto the chain saw. Here we can adjust the piece spacing to create more or less geometry. And here onto the helix, we can adjust the height and also the number of turns. And onto the chain saw, under the chain pattern, let's go into the transformation and let's enable the scale, so we can scale our geometry along a curve. So we can enable the scale ramp. So here we have the ramp to adjust the scale, and let's enable the rotation and let's enable the rotation scale ramp. Here we have the base rotation. Let's add some rotation. So here we can adjust the ramp to where we want the rotation to happen. Okay. So here, as you can see, our first piece is not correct. So what we can do, we can add a reverse node to reverse the direction of our helix. So here we are starting correctly, and at the end we have the ending geometry correctly. We can create another box and use this box as an end piece to add an end cap. Okay, so that's the chain SOP.